Hello, everyone, and welcome to the latest episode in our virtual event series covering the electrification of private and public sector fleets. I'm Alana Weitzman, Vice President of Strategic Development, Clean Transportation at Electric Autonomy, and I'm excited to introduce this installment of the EV Fleets Pro virtual event series, Under Construction, Electric Vehicles for Civil Works. Before we dive into today's discussion, I'd like to thank takeCHARGE for supporting today's session. I'm also very excited to announce that we have partnered with takeCHARGE to launch the very first syndicated version of the EV Fleets Pro course. Fleet customers of Newfoundland Power and Newfoundland and Labrador Hydro will be able to take the course alongside all the fantastic existing programming that takeCHARGE provides. It is currently in a soft launch phase, but my colleague will share the website information in the chat, and I encourage you to head over and enroll in the free course. If you are interested in licensing the course for your customers, please get in touch with us. Before we get started, I'll take a moment to acknowledge that our work at Electric Autonomy is conducted from the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. Now, I'm very happy to introduce you to our panelists. If I can ask them all to switch on their cameras. We have Peter Upshall, Energy Management Engineer at Newfoundland Power and takeCHARGE. Dr. Ray Gallant, Vice President, Sustainability and Productivity Services at Volvo Construction Equipment. Christopher Ralph, Director of Smart Mobility and Electrification at Norda Stelo. And our moderator for today, Emma Jarratt, my colleague and Executive Editor at Electric Autonomy. And now on to the topic at hand. I see that Emma is perfectly dressed for the occasion, so over to you.
Thank you so much. I was told I could dress in theme. It's great to have everyone here today, and thank you so much to our audience as well, who has supplied some amazing questions even before this discussion kicked off. Just a quick note on that. We got thematically some very similar questions, so to save time, they've been grouped together. So if you don't hear your exact question asked, it's not that it wasn't an excellent question, it was just we had to slightly rephrase to make sure we got to as many of them as possible. I'm going to take this off before my children see me and lose their mind that I'm wearing one of their toys. All right, Ray, let's begin with you today. This was a very popular question amongst the audience, and also one that was top of mind for me. Where should we start with all of this? A mid-size excavator, a dump truck, a Lightning 150 on a site? Which equipment is most suitable for electrification, and what is available today?
Well, there's nothing like starting with a really easy question. I think first, when we start talking about electrification, we have to kind of take a step back and realize that electrification is not new in the construction industry or the automotive industry or transport industries. We've been using electric motors and electric controls for well over 100 years. So this is technology that we are familiar with. What is new is the influx of new technologies that bring different solutions or different ways of electrifying to the market and to our industry. And I think that's what's exciting about this transition that we're going through. So we see basically 5 different technologies that move us towards a more sustainable power fleet or power source for our fleets. Battery electric, obviously, we're familiar with, and that's what comes to mind because people are familiar with the automotive transition to battery electric cars. So automatically, when you start talking electrification, everybody jumps on the battery electric bandwagon, if you will, as being a possible solution. And that is a very good solution for fairly low power applications and a fairly short duty cycle. Beyond about 6 to 8 hours duty cycle and about 150 to 200 horsepower engine draw or engine equivalent power, you're going to run out of space to put batteries. You're going to run out into too heavy a battery installation, cooling issues, and a number of other problems with the technology beyond that scope. So we need to move to other solutions. So obviously, if you're in an area where you can connect a machine directly to the grid, you can draw your power from the grid without having to have a large battery pack and carry the power with you. That is an excellent solution if your site is amicable to that. You can also use a number of different hybrid solutions and hybrid attachments that can go a long way into making your machines more efficient and electrifying or using sustainable power for those. And finally, there are a number of alternate fuels out there that you can use, including biofuels, renewable diesel, that have a much lower carbon footprint than the traditional petroleum diesel. And that includes hydrogen, which you hear a lot about now, either in terms of hydrogen fuel cells or hydrogen combustion engines, to power the extreme heavy duty applications, thousands of horsepower and 24-hour duty cycles. So that is probably the best solution when you get into those very, very heavy pieces of equipment, if you cannot connect directly to the grid. So short answer to the question, it depends. You really have to look at your job site, what you're trying to do, what your goals are, and then pick solutions and technologies that are upcoming that will allow you to achieve that. There is no one answer to the electrification or sustainable power for construction job sites.
Thanks so much. So, Christopher, I want to run with that idea that this isn't a one-size-fits-all solution. Can you talk to us about some case studies or examples of sites in North America that have successfully deployed decarbonized equipment, whether that's full battery electric, wired, or hydrogen?
Sure. That's a fantastic question. Thank you, Dr. Gallant, for providing that context and that overview. Right now, when we talk about civil construction, we need to understand that civil works can vary from a guy or a gal with a jackhammer at his job site all the way up to some of the largest pieces of equipment that we have in North America. So I'll provide a couple examples today of what's actually going on with real-world examples that we can point to in Canada. The first is for a lot of people who live in the Greater Toronto area. Currently, if you're driving down the 410, 401, or the 407 through Vaughan, you're actually going to see a ton of the heaviest electric vehicles offered in North America. And those are your electric tower cranes. These are already a common sight on job sites across the country. Many of them are wired into the grid at temporary services provided by the local utility, and many of them also run on electric generators. They offer significant benefits over a diesel tower crane, largely because they have considerably less maintenance. They're a much more predictable power output, and if they because of the instant torque on them, are able to lift and haul with considerably more, not necessarily more power. And Dr. Gallant can explain this why later on in the conversation. But it is an instant torque and instant feeling that allows the driver or the conductor of these pieces of equipment to feel like there's considerably more power. It also expedites a lot of things on the job site. But moving onwards, we can take a look at battery electric vehicles as well that are very, very common. For those in Ontario and British Columbia, Aecon is actually a large construction company that operates inside the property management and construction space. They have a very large fleet of Ford F-150 E-Lightnings, which are, your crew cab transporters. You can transport and haul stacks of tools or bags of cement, or even your people from one end of the job site to the other. These are very common on job sites across Canada, but Aecon's even going one step further. They're moving into some of the smaller class 5s, I want to say, class 4 or 5, excavators that are battery electric as well. They have a few of them operating in Ontario on a test case basis. And then as we move further along the battery side, Lafarge Holcim actually is the cement company is actually operating electric vehicles today in aggregates. So a lot of these vehicles they're operating are not necessarily the cement trucks. It's the secondary support vehicles that go to job site and carry, cement mixers and a lot of the other ancillary equipment that stand behind the cement trucks themselves. And lastly, if we look at New Gold, or if we look at any of the potash mines in Saskatchewan, or Northern Alberta, they're actually bringing over European-built electric vehicles to do a lot of the off-site, off-grid construction. And the reason is not because it's necessarily easier. You now have to change your duty cycle, but they offer considerable advantages over diesel. For example, they're able to go underground without requiring additional emissions control or additional noise control. And when you're thinking about job sites that are happening in urban areas, especially for the construction of new towers, condo towers, or operating in residential areas, or in refineries or industrial settings where noise considerations are absolute and vibrations are paramount, electrification offers those types of benefits. So those are 4 examples that are happening today in Canada that we can all point to and look at and learn from.
Thanks so much. So, Peter, picking up that thread of this is happening now, utilities are having to cope with these vehicles, whether they're wired into the grid or they are, needing to charge in between their duty cycles. This is a brave new frontier. So, what are your utilities' initial learnings about what's involved in powering some of these sites or vehicles, special considerations now for these construction projects?
Yeah, I'd start off by saying in Newfoundland, we're certainly welcoming electrification, but it is very early days here. So we're a little behind, Ontario and some other jurisdictions, especially with very heavy equipment. We are getting inquiries from customers looking at, what the possibilities are. The local Metrobus company is looking at electrifying some of its fleet and several sites where they want to get power. So, at the early feasibility stage, they were coming to us wanting to make sure that, 3 of the sites, for example, that they're interested in were going to be feasible for them. And from the utility perspective, that means making sure that we can get the power supply to them where they need it. We've also got another customer in particular looking at a 5 megawatt load for new electrified equipment. And that is significant. That's, to try to put it in some context, that's probably 500 electrically heated homes here in Newfoundland, which is pretty common, or 1,000 regular homes, maybe, just to try to get an idea. So that is a significant piece of electrical load to add, and it's going to need a lot of planning from the utility side to make sure that we can get the power to that customer when they need it, for sure. So, maybe the early lesson is that it is so important for customers to come to us early with what often are very big electrical loads to add to the system to make sure that we can get the ball rolling and have our plans in place and be prepared to get the work done so that when the customer needs that power, we're able to get it to them.
Yeah, it almost presents like a bit of a chicken and an egg problem. Like the customer needs to come to you to say, like, we need this load, but even before that, they need to figure out what it is they actually need. So, Christopher,
For sure.
I'm going to bounce back to you for a second and ask you to walk us through like the ideal way that companies can handle, for lack of a better term, drafting up a charging plan. Is there a best practice for how to set up a work site, how to assess what you need? If you could take us through that, that'd be great.
Sure. So, for context, Norda Stelo actually offers fleet consultation services. What we'll actually do is we'll take a look at your fleet today, the tasks that you're working on, and match up vehicle to task, man hours or labor hours, and what exactly you're trying to accomplish, and then select tools for that job. A great way to look at this or approach this is to take a look at industries that have already electrified. And a great example of this is the delivery industry that now is on its 7th, 8th, 9th year of electric vehicles, and all the large players from Canada Post to Intelcom to Amazon or whatever, they all have electric vehicles in service. If you're in Quebec, you're probably getting an electric vehicle delivering your packages. And what they actually began with were small-scale fleet pilot projects. I'll reference a couple of them. Selecting the vehicle has to come before selecting the charging plan. And selecting the vehicle means that you need to understand what you are attempting to actually do. A vehicle is a tool. Construction companies understand that. Civil works firms understand that. Property managers understand that. Selecting your tool means you need to understand your job. And having a fleet analysis done will inform your charging plan. What this means is that you may actually realize that you can use alternative vehicles to do what you are doing today. And Dr. Gallant can actually speak to this later on. I think he's already brought it up with your method of propulsion might actually change or be different depending on where you are and what you are doing. If you're close to if you're in an urban dense area and you have a grid tied system, you might not need battery electric vehicles. You might be able to get away with grid tied. They're still electric. They just don't have batteries and there's less weight on them. What we actually saw in the delivery space was a shift in the type of vehicle. A lot of vehicle sizes went down and we moved to alternative delivery methodologies like electric cargo bikes moving around the downtown. A charging plan for an electric cargo bike, you can plug into a 110 outlet. It's very different. It does not necessitate a large EV charger. But a lot of the other vehicles actually moved up a class size because now you're able to use the efficiency of an electric vehicle to better cube out vehicles as well as to do more with less. You can now make more trips for less cost interdepot. So last mile vehicle size went down, interdepot vehicle size went up, or trips increased. Construction companies are going to be faced with sort of the same mentality. When you're moving to a Ford F-150e Lightning, it's very different from a regular Ford F-150 in that you now have vehicle-to-load capability, which means you're now able to not necessarily need a generator to power up a battery bank for all of your Ryobi or DeWalt drills for a lot of your crew. You can now do that on your vehicle. These types of cost savings are going to change with the vehicle, and the vehicle will necessitate the charging plan. How to make sure that you maximize the strength of what you're doing is to start with pilots. Don't necessarily go out and buy the biggest vehicle until you are comfortable operating electric vehicles. Otherwise, it can turn into a very expensive paperweight. You need to understand what your end result is going to be and work backwards from that rather than immediately selecting a vehicle and hoping for the best. Plan for the worst and plan for the best, whatever that expression is. You need to make your plans correctly to avoid catastrophe. A lot of the vehicle fleets today that are advancing very, very fast into the electrification space, deploying hundreds of electric vehicles, have already laid the groundwork and done the engineering to plan their fleet, understanding their objectives, their fuel costs, their monetization, their payback periods. They haven't just been buying vehicles. The place to start is in Excel rather than on the dealership lot.
So just drilling down for like another moment on that. So before anyone can talk to Peter, for instance, about what they need from the utility, and before anyone can talk to Ray about the types of vehicles that they want, they're talking to you or somebody like you about the plan. Yeah. How long does that planning phase take?
It can be surprisingly quick. And the reason for that is because companies know what they do. They know what they do. They're typically only executing on one or two specific things. A construction firm that is in, brownfield understands how to go into a building, retrofit. They're utilizing the same types of vehicles and they're doing the same types of tasks. Defining by tasks means that you can now isolate and find the right vehicle or the right tool for the job, find an electric equivalent, and build around that. What that would allow me to do is determine a number of vehicles, a relative cost, and a charging plan that is going to last you for 5 to 10 years or even longer, or job to job specific, which means I can then go to Peter with a load summary and say, I'm going to have this number of vehicles at this number of chargers, and you need to provide me X number of KW or MW. It also allows the company at that point to, at the same time, approach Ray and say, we would like to have equivalent to perform these tasks. And we don't typically recommend a vehicle. We recommend a vehicle class because, as Ray has mentioned, getting an excavator that's battery tied offers significant advantages and disadvantages. There are grid tied versions, just as there are hydrogen prototypes coming out. And there are alternatives as well. Maybe what you are looking for today is to electrify a different part of your fleet and wait for prices to come down or new models to emerge at different times. Great example of that is in mining. Some of the largest mining trucks today are simply not available in the electric powertrain or in the electric battery models that they require. That does not mean they can't start their electrification journey, nor does it mean that they need to stop planning their charging needs. What they can do is plan for a later date, get the plans in place now, have the service installed, and not have to wait when their vehicle arrives to have a charger installed and wait 6 months to 12 months for a utility service. They can have that already put together.
Thanks.
If I could just jump in quickly on that point, when you're doing the planning, one of the things we always look at is, do you have power available? So if you have grid power available or can be brought into the site, you contact Peter in time, bring it into the site. It's fairly easy to set up a charging infrastructure. You just purchase the chargers and wire them in. If you don't have the grid power available, or if it's an extremely remote site where it doesn't even exist there, then there are solutions out there where you can carry the electricity actually to the work site. So best battery energy storage systems where you can actually charge up off the grid and then truck it out to the work site and charge the machines. And finally, in extreme remote job sites, especially the larger ones like mines, you will see contractors and customers generating their own electricity, either with a hydro plant, a diesel generator, a number of different methods that they can generate their own electricity on site. So again, don't get hung up if the solution isn't obvious and in front of you. There are different technologies coming into play that will make charging possible on whatever site you're on.
Ray, I'm just going to ask you to keep on trucking, as they say, and talk about the benefits of these vehicles. We've gotten a couple questions, and I mean, I think, at least for me, like my takeaway thus far has been this is possible. There are some benefits to doing it, but it is a lot of work. So the natural follow is, okay, well, is the doing all that work worth it? So let's talk about what the vehicles actually offer in terms of idling, cost to refuel, the power of the equipment. Do they function the same? And this is a aggregation of a whole bunch of different audience questions that wanted to tap into this particular issue.
Yeah, I actually often talk about the questions that I most often get in my presentations, and number one is, will it perform the same as my existing machine or my diesel machine? Consistently, what we found is yes, the operators jump off the machine and say they swear it's more powerful, more comfortable than their existing machine. Comfort because of low noise, low vibration, no emissions, no fumes, no smell. They appreciate that, especially at the end of an 8 or 10 hour shift. But also the power and the machines, if you look at the engineering specs, they're designed to be exactly the same specifications as the machine as a diesel equivalent. And the reason for doing that is so that the operators are not surprised when they get in from one machine to another. It's what they're used to in terms of power and control and feel of the machine. What they're feeling, and the reason they say it's more powerful, is because you've got instant torque. An electric motor, unlike a diesel, does not have to go into its ideal power range or ideal RPM range to get maximum torque. On an electric motor, the torque is fairly flat all the way across, and your power from the battery is instantaneous. So that's really what they're feeling. They're not more powerful necessarily, they're more reactive than their diesel counterparts. The other big advantages to the electric machines, like the one you see on the background behind us, is that their operating costs are significantly lower. So we've done some testing in California and actually all across North America. And what we're consistently finding is the operating cost for one of these machines is about 80% less per hour than the equivalent diesel machine. So that has two implications. One, we all know that the capital cost, the acquisition cost of an electric machine, because of the technology, is much higher. So the operating cost has to be lower to make it economically viable. So basically the conclusion there is you have to work these machines to have the payback on them. If you're going to buy a machine, sit in your yard just to say you're green, you're actually not doing any good for the environment, because the machine was actually more carbon intensive to build than the regular diesel. But if you're going to work it a few hours, then you're gaining back all that economic output in the beginning and the emissions output, and you're very quickly making it back. So initial calculations, because of the lower maintenance, because of the low noise, all those factors, our initial view is that we're going to be about payback economically in about 4,000 hours, which for a machine like the one in back of you is about 2 years use. And considering that these machines work 8 to 10 years, the economic equation over the lifetime becomes very good. However, what this means is that the customers have to have considerably more upfront capital, or we have to put in finance plans that allow them to float that capital up front until the operating costs pay back and you get out of that upfront capital stream. So it is a different financial equation, but to answer people's objections on the economics, we're now seeing that these are much, much more economical to run over the lifetime of the machine, which is very positive for what we're trying to do. The other thing that I'll mention is these are right now first generation machines. There's a question in the chat about can we do a conversion? That's essentially what we've done in these first generation machines. We've essentially taken out a diesel engine and put in a battery pack and electric drives to drive the hydraulic system to operate the machine. There are two reasons for doing that. One is because you minimize the number of new parts, new designs you need. So from a quality point of view, we know we can provide a high quality on the hydraulics, the booms, arms, chassis, all those components already. So by only replacing the engine, we made sure that the quality of the machine was kept very, very high. The other reason for doing it is, of course, economics, and to get the machines out there, to get feedback from the customers and to learn how these new technologies will work in real world applications. But with that, we can start to design second generation machines, where to me, this is where it gets very interesting, because now you have an electrical backbone in the machine, you have precision controls, you have sensors in the machine, you can start doing it tasks autonomously, start getting much more efficiency with the machine, start communicating from machine to machine, and planning your work site with a lot more efficiency. So not only do we want to get the fuel burn down and get more efficient with our energy use across these sites to make them more sustainable, we need to overall lower the efficiency, or another way of saying it is get more work done with less power. And if we can do that, then we can solve these. And that's where I think the second and third generation electrics that take advantage of this constant torque curve, the low noise, the different environments you can put these machines in, will be really exciting in the next few years.
Oh, my question, right? I was going to save the conversion one for later. No, I'm excited that you answered that, though. I was very curious. It was a great question. We had a couple come in about the conversion piece. But I know, Peter, the idea of doing more work with less power is a bit of music to your ears. Mm-hmm. So I want to make you just king of the world for a second. If you were king of the world, how would you like construction companies, like really just beginning their electrification journey, to do with respect to their interactions with utilities? At what point do you want them to start talking to you? Is there a world in which the utility and the construction company kind of partner up to share learnings and data and start building a knowledge base?
Yeah, so just to repeat myself, we want to talk to customers early in their process. But as Ray and Christopher have been mapping out, it's important for customers to learn about the technology, to learn what the options are, so that if they are able to come with us a plan and say, we need this much power because we're going to convert these number of vehicles and so on, that's ideal. If I'm king of the world, so they come to us and they say, yeah, we need 2,000 kilowatts or 2 MVA of power, and we need it at this location. Now we can start the planning and just make sure that we're able to supply that. And in a perfect world, maybe if I'm king, I get to decide that. But we don't need to do many upgrades. We just have to put in a transformer for that particular site. But certainly the reality is that there will be places where there needs to be upgrades to our distribution system to be able to supply that customer. And that's when it's, the months start adding up in terms of how long it takes to make those upgrades, for sure. Yeah, and we were happy to provide the customers with the power and to serve them. We just need to allow enough time to do it. Ray alluded to the fact that some customers may be, in isolated locations, and that's going to mean probably even more work, more costs. The reality is the way electric utilities are set up is that in cases, customers need to make contributions to the cost of building a distribution line, and it goes into a formula that determines how much electricity are they going to use, what is the cost to do that, and then the customer may have to make a contribution to us. So all of those things can be figured out in advance. And if customers have some choices, to locate or to have a charging facility at location A or at location B, some of the information and the costs that we bring to the table can influence, which location they go to, A or B. So again, those early conversations are good, but ideally they come with some information and idea about how they want to do that electrification process. And if you told me I'm king of the world, I'm feeling good now. The other thing that Ray alluded to that I wanted to make a quick comment about is that, that constant torque. And for most of us, people that don't drive heavy equipment, if we do get to drive an electric vehicle, we experience the same sort of thing in terms of, when you're starting out and you put your foot on the accelerator and the vehicle just takes off right away with little or no hesitation. And it feels kind of fun to drive, but I presume some of the heavy equipment operators are, experience the same thing, except with a big machine.
Well, I like how you took the king's crown and ran with it.
Thank you for that.
Really, really interesting points there, and a good, some good tips for companies looking to start this process. I'm going to make a bit of an executive decision here and say we should move into audience questions because the Q&A chat is bumping right now. If we have time at the end, I'll come back to my last couple, but there's some really excellent questions in there, particularly a top one is around clean fuel regulation credits. And Christopher, I saw you flagged the question in the chat saying you're going to answer it live. So I don't know if you want to kick us off with that, but there's a lot of curiosity around how CFR is going to apply in this circumstance and who gets the credit and how it all works.
Sure. So first off, it's a very interesting question because it focuses on the economics around electric vehicles. And there are two schools of thought around this, and the practical and largest one in Canada is the more you use an electric vehicle, the more profitable it becomes. So Ray is absolutely correct. I've spent 4 years working for an electric vehicle manufacturer. We said the exact same thing. 80% cost savings on fuel, 60 to 70% savings on maintenance. Very simple cost metrics. Higher capital, long payback period. The more you utilize the vehicle, the quicker that payback period becomes, but also the steeper you can start to drive down your costs. In the construction space, that means you want to monetize everything. A vehicle offers not just cost savings, It doesn't just offer insurance savings. They are typically cheaper to insure. It also offers the ability to monetize additional revenue. Now, this becomes important. Depending on your jurisdiction, you are able to monetize federal clean fuel regulation credits if you are the proprietor of the electric vehicle charger. That means that you have to have a registered electric vehicle charging system that pulls power from the grid and powers up your vehicle. Temporary charging solutions on construction sites do qualify in Canada, in California for credits. They qualify in a lot of Western states, in New England and New York states as well. There's also the ability to register if you are in an industrial application and you are displacing natural gas power or power from diesel sources on specific carbon markets. Quebec and California offer examples of this as well, on how if you operate a mine and you are actually displacing specific fuels during these times by grid tying, moving to batteries, there's a bunch of formulas that sit in this. There's a potential there for additional credit monetization. All of this is to state that going back to your plan on what your fleet is, a charging plan should also be able to monetize you those credits. It should be able to dictate how you are going to derive your payback, whether it's going to be paid in just operational savings or whether there's more to it than just that. This also goes back to the vehicle to load question, which is the last school of thought. The more you do with an electric vehicle, the lower your costs are elsewhere. This is fantastic when you think about generation systems. If you move to battery electric systems or the ability to power hand tools from a Ford F-150 Lightning, you are now reducing operational costs that would otherwise have to be eaten in a different division of your construction company. That means there are ancillary cost benefits that need to be planned out. And Dr. Gallant had a fantastic point about this. You can use a battery energy storage system to move around your site to power up your electric excavator if you don't want to move your excavator, 10 kilometers back to your depot where your charger is located. But you can do more with just that battery electric system. It can respond to demand during peak times, and understanding how you can now monetize not only those credits, but ease the burden on the utility as well, means that you might not be submitting a load summary for 10 MW, it might only be 4. And as Peter will tell you, the cost considerations for every kilowatt and every megawatt when you have to pay for poles to be installed for a new utility line add up. That charging plan for your electrification journey has a wide variety of ancillary cost benefits that go far beyond just the carbon credits that you can capture. And all of that should be explored in your fleet plan as you are beginning your pilot stage. It's a very long-winded answer of saying yes to that question.
And is that something that is it sounds like it's assessed during that project evaluation part?
Absolutely. The credits would typically be offered over the lifespan of a project or year by year based on the vehicle contribution and who owns the charger. Having all of that planned in advance will allow you to not just register and take advantage of those credits, but to understand your potential payback, use case scenario, and then you can go to your CFO and the accountants in the company and say, here's our expected payback for this project.
Yeah, we're going to pick up that thread in a second about the financial piece, because there's another great question about that. But just very quickly, Ray, we've got a couple, I think they're quick, maybe I'm wrong, questions that I just want to fire at you so that we get those answers up quickly. So first off, someone's asking, what will the reliability of EV vehicles used for civil works be compared to ICE vehicles? So essentially, if I'm reading that correctly, can they do the job? The same, better, worse?
We're actually, and Christopher mentioned it, we're seeing, or on some types of equipment, you're seeing 50 to 60% less maintenance costs. We're actually, in our design plans, we thought it'd be about 35%. It's actually coming out in our long-term trials much higher than that. And the reason is twofold. One, diesel engines have a lot of moving parts, a lot of fluids, filters, especially when you get some of the after treatment systems on it. There's a lot of maintenance involved. Most of that goes away with an electric drive. You still have a hydraulic fluid to maintain, but that's very easy compared to engine oils and things like that. And the second thing is that these machines, electric machines, don't have the same idle characteristics as a diesel. So if you're in a country like Canada, where it's cold during the year, during most of the year, half the year, your operators are running the diesel engine basically to run the heater in the cab a lot of times. And it's sitting there waiting for some other job or a truck to come by or whatever. With electric machine, you don't have to do that. The heater runs off the battery electric drive, but takes very little power compared to the machine. And when he's not operating the work implements, basically the machine is shut down for all intents and purposes. So with an excavator like you see in the background, we have as much as 30 to 40% idle time that's eliminated with an electric excavator that would be present on a diesel equivalent. So that's 30 or 40% less fuel hours that you're burning. And it's also a lot less wear on the machine, because during the idle period, the only thing you're putting wear on is the heater switches.
Great. And then very specific one, do you know when it's projected that EV haul trucks will replace diesel 25-ton trucks?
25 ton?
Yeah.
We're putting out, and this is our plan, is to put out battery electric haul trucks, starting with battery electric haul trucks in about 2 to 3 years. One of the caveats there is, again, and this fits well into our conversation, you need to have the site prepared for it. So this isn't, a haul truck isn't something that you can replace 1 out of 5 with electric and leave the other 4 diesel. That just won't be an efficient operation. So you have to plan. So we're looking at basically new sites or new operations in a site that can go all electric, including the haul trucks, the load instruments, excavators and loaders and things like that, and doing the whole site electrified. And when you do that, there's a lot of benefits.
Good news for that question. All right, and then the last sort of semi-rapid fire one, just picking up the conversion thread. We've had a couple really specific questions about the conversion part of this. So for instance, we have a mid-size excavator that needs a new engine. Is it viable to convert this machine to electric? Does any company do this for construction equipment?
Yes, there are companies that do that. It is viable, but it's not cheap. There are quite a few changes that need to be done in the machine. And the other caution I would have is that it's more than just replacing, because the torque characteristics are different. You have to be a little careful that your engine, that your hydraulics, your drive systems and everything are tuned properly with the electrics. So, as I said, these are generation 1 machines. For us, it was easy to drop a battery and an electric motor in. The time, the development, and the cost, quite honestly, went to making it all work together seamlessly, efficiently, and predictably. That's where we spent most of our research dollars. So it is possible. Yes, there are firms out there that can do it. Some of them do a very good job, and I can give names of some firms that I'm familiar with if you want to contact me directly. But you do get a conversion machine, not a purpose-built machine in that case.
That's correct. I just want to jump in on that. Think about the lifespan of your vehicle. If you buy a conversion, how long are you going to use it for? Is your conversion going to last you the 10 to 12 years lifespan that you're anticipating using it for? Are your job needs going to change in 10 to 12 years? And most importantly, if your competitors buy newer equipment, or as Dr. Gallant said, Gen 2 equipment when it's available, What is their cost savings going to be versus your incremental when you're both bidding on the same job? That's really the methodology we utilize when we do a fleet plan for it. There are companies that do conversions, but I also like to hearken back to the days of 2018, 2019, when electric vehicles in trucks, class 5, 6, 7 trucks were really just getting going. Those started as conversions, and the minute Gen 1 vehicles became available, they ran roughshod over the conversions, and now we don't even talk about them anymore. They're not even around. Purpose-built will always be converted, but there are use cases for it today if you are in a pinch or if you're only converting a small number of vehicles.
Great, thanks. And then I'd said before that I wanted to keep going in the financial piece. We've got a really good question. What can be done about financial institutions not factoring in fuel savings and reduced maintenance costs for equipment loans? And maybe I'm going to broaden that out a tiny little bit, because each of you bring a different piece of the financial puzzle through your specific roles. Peter, maybe we'll start with you. And I guess broadly, the question is, sometimes getting power to a site or upgrading the infrastructure to get power to a site can be prohibitively costly. Are there any financial breaks that you know of or that you can point people to that they should look into to sort of ease that just a tiny bit?
Gee, good question, but you've stumped me. I really don't have a good answer in terms of places to get, financial contributions. I could try to be a little bit coy, so I've already tipped my hat and say that, when we look at the full cost of building a line, I'm just going to grab a number and say, if it's $1 million to build a line, then we look at how much electricity is going to be used by that customer at that site, and there's a cost sharing arrangement. So, in the end, the customer doesn't pay the full amount. We're cost sharing with them based on future revenues from that customer. So that's part of it, and unless there's a government program that I'm not aware of, just the fact that if they're going to be displacing fossil burning fuels, then there may be some credits that they're eligible for, as Christopher alluded to as well. But that's maybe not very much compared to big costs.
Yeah, to be
Hopefully
honest,
somebody has an answer.
I know, because I don't know either. You don't hear a lot about like costs or grants or funding that will help with just getting the power to the site. So anyways, spot for me to look into too. All right, Ray and Christopher, obviously your cost pieces are important as well. So, Ray, do you want to just go through anything that can be used to help offset the upfront cost of an electrical equivalent to diesel heavy equipment?
Yeah, there are a lot of programs out there, depending on which province or which state you're in, if you're in the US, that are available to offset for the heavy equipment acquisition. Some of them have scrap requirements, so you have to take a diesel machine out of commission when you buy the electric. Some of them, it's just a straight rebate on the electric purchase. The big change that I think you're going to see in the industry over the next few years is the finance companies figuring out that batteries are not like a fuel tank. So at the end of 5 years, your fuel tank is worth pennies in the terms of the machine, because all it is sheet metal. With a battery, even at the end of 5 years or 10 years, when your battery life is depleted, it's still very, very valuable. And in fact, our depletion rate for heavy equipment, we say if the battery degrades to 80%, we need to get it out of there, get a new battery in, so you get your full duty cycle out of the machine again. Well, that battery that's depleted to 80% is still perfect for a household system or a solar field or a wind farm or any of those other uses that need battery electric storage. So one of the things, and Peter can tell us more about this than I ever could, but one of the difficulties with electricity is it's hard and expensive to store, and it's hard to get to where it's easy to generate electricity. It's hard to get it to the spot you need in the time you need it. because of the storage and the transmission. So these batteries, even though they're not suitable possibly for a machine use, still have a lot of other uses. So we've got to get the finance companies to be putting a value on that, if not even financing the batteries separately. So they say, okay, we'll finance 5 years for 30% of the battery, but then we own the battery at the end, the 70% value that's still left. So we're working with different finance companies to, first of all, get the history so they can make those determinations, and then come up with plans and terms that allow the customers to do that and take full advantage of the residual value that's in those batteries.
Very cool.
That's awesome. No, that's exactly correct. I think vehicle to grid also explains a lot of how we can create financial solutions here. When your vehicles are idle or on downtime, you also have the ability to sell power back to the grid, and you can do so with your vehicles when they're not on a job site. If you're parking them in a lot, being able to use those vehicles as energy storage systems, or their batteries at the end of the use life of 15 years or 12 years as energy storage, is absolutely the methodology by which you can now convince companies and financial lenders to monetize the whole of that project. And we are actually starting to see them do that. There are companies in Canada that are run by the financial institutions on Bay Street that are starting to take on the 10, 20, 30-year power purchase agreements for V2G. They are starting to take a look at buying the batteries off of you. They are beginning to financially incentivize that in Canada and the United States today. But it, again, is slow going. The financial sector does not necessarily possess the knowledge that the electric vehicle industry has, or that engineering firms have, or construction companies have on those specific use cases, which again goes back to planning. Creating those plans up front and then approaching for financing once you already now have a total cost of ownership usually results in a very different conversation than approaching a financial institution midway through a project and asking to electrify halfway through. The planning component typically informs the financial conversation.
Those are 3 great pieces of advice. Can we do this in under a minute? Yes, I think so. Okay, I want to end on a really optimistic question from the audience. In a sentence only, please. From each of you, what are you most excited about for an EV solution coming to market this year? We'll go in reverse order. So Christopher, you first.
Holy geez, what am I most excited about for? I'm excited for the revolutionary rise of Class 8 trucks being able to move construction equipment, shipping equipment, and materials and aggregates from port to port, port to depot. We're already seeing Volvo NVRs, we're seeing Mack, Freightliner, and all the big guys roll out this year. And the number of electric vehicles just in Quebec in the heavy class alone is set to double this year. So that's what's got me going.
I think you almost did that in one sentence in one breath. That was impressive. All right, Ray, what's your one sentence?
I think what I'm most excited about is actually the convergence of different technologies. So when you start looking at all the different solutions and bring in new technologies like AI that everybody's talking about now, this is, and different partnerships, it's not just inventing a new diesel engine or a new hydraulic pump. It's how do we control work between different machines? That's what becomes really exciting in terms of productivity and efficiency, leaps forward, and safety and health and all those other benefits.
Well, thank you. And Peter, last word to you.
Yeah, I'm going to say, we're excited to serve our customers as they start to electrify and discover the benefits that we've been hearing about from Ray and Christopher. So yeah, there are lots of great benefits from electric vehicles. It's early days for us in Newfoundland, and yeah, we're just excited to keep serving our customers with electricity as they discover the benefits of electric vehicles.
Amazing. You did it in a minute. Thank you all so much. Really appreciate it. That was an excellent discussion on a really cool emerging area. And we appreciate you for coming and being so candid, and to our audience who was just fantastic with your questions. Made my job incredibly easy. Alana, I'm going to pass the the hard hat back over to you. And thanks again, everyone.
I will also thank everyone, Peter, Christopher, Ray, and Emma, for today's discussion, and again to our audience for contributing your questions. I also want to give a big thanks to Gail Noble at takeCHARGE, who suggested the topic of today's discussion. And thank you to everyone at takeCHARGE for being such great partners in the EV Fleets Pro program. Before everyone signs off, I also want to tell you about two great in-person events that we have coming up on the calendar at Electric Autonomy. First is our conference on advanced EV manufacturing, the EV Innovation and Technology Conference, where we focus on all aspects of the EV supply chain up until the vehicle rolls off the factory floor. A few tickets are still available for this event on February 6th. I think it will be especially lively considering the current political moment. And this takes place at York University in Toronto, and I recommend booking your ticket today if that's of interest, because passes are limited. And of course, for anyone who is looking to electrify a fleet, the EV and Charging Expo is a must attend. You can expect 2 days of conference programming with over 100 speakers on 4 stages, a large exhibit hall where you can chat with best-in-class experts, and a ride and drive experience where you can take the wheel of commercial suitable electric vehicles. We'll have increased programming this year for municipalities, alongside our great content on public charging, fleet electrification, charging for multi-unit residential, and so much more. We expect to release the program and speaker lineup in the coming weeks. So thank you to everyone for being here with us today, and have a great rest of your day.
Thanks. See you, folks.
Bye.
I'll see you guys.
Thank you.